In 1.3, we're going to look at fitting points to a polynomial. So you've done this before when you're given 2 points and you're told to find the line that that contains both points. So we're going to start with lines, and we're going to do this slightly differently. Instead of plugging into y equals mx plus b and figuring out the slope and then getting the y-intercept, what we're going to do is we're going to plug in the point to each given point into ax plus b equals y. That's going to give us a system of equations to solve, and that'll help us get our line. Now, this might seem more complicated than just using the old method, but the difference is this scales well if you're trying to fit 3 points to a parabola or 4 points to a cubic. So let's start out with a line and do this example. All right, so find the equation of the line that goes between these 2 points here. All right, what I'm going to do is for each point, I'm going to write out ax plus b equals y. So for the point 1, 5, all I'm going to do is replace the x with 1 and the y with 5. And for 4, negative 1, I'm going to replace the x with 4 and the y with negative 1. So now I've got a system of 2 equations and 2 unknowns. Now I'm going to rewrite that as the matrix 1, 1, 5, 4, 1, negative 1, and I'm going to solve this. Now, I've already got a 1 up here, so let's use that to zero out the 4 below. Row 2 minus 4 row 1 is going to give me 4 minus 4, 1 minus 4, and then negative 1 minus 20. So it's negative 21. Now the goal here is to solve this system, and now that we've got it into this form, let's use back substitution to figure out the solution. Now remember, our variables here are a and b. So this bottom line tells me negative 3b equals negative 21. So b is 7. And if I take that and plug in, the top line says a plus b equals 5. So that's a plus 7 equals 5. So that gives me a equals negative 2. So my answer here is, I'm just going to plug back into this over here. My answer is negative 2x plus b, what was b, negative 7, equals y. And that's our answer.